Parker Solar Probe vs Blowtorch, watch a blazing hot showdown. By Elizabeth Howell, Space.com contributor July 24, 2018, 11:57 a.m. Eastern Time. NASA's next solar spacecraft can withstand so much heat that even a blowtorch won't disturb the probe's shield, a new video shows. The Parker Solar Probe, which is targeted for liftoff sometime between August 6 and 19 from Space Launch Complex 37 at Cape Canaveral Air Force Station in Florida, will be the first NASA spacecraft to touch the Sun, or to directly contact the coronal material in the Sun's fiercely hot upper atmosphere. During its 7-year mission orbiting the Sun, Parker will swoop as close as 4 million miles, 6.4 million kilometers, to the Sun's photosphere, which is the layer of the star we think of as the surface. The centerpiece of Parker's sun protection is a special heat shield that uses a carbon composite foam sandwiched between two carbon plates, NASA officials said in a statement. The side facing the Sun is coated with white ceramic paint to reflect the heat. NASA mission to touch the Sun due to launch in early August. It's very lightweight, as you can see, Betsy Congdon, lead engineer for the heat shield at the Johns Hopkins Applied Physics Laboratory, UAPL, in Baltimore, said in the new NASA video. She lifted the bulky shield fragment easily with her hands. "Here I've got a blowtorch," she added, "and I'm going to use it to get the front surface glowing hot, and then we'll have a nice demonstrator come in and touch this at the back." In less than a minute, Congdon had the shield glowing red with the help of her blowtorch, which boosted the temperature at the front of the shield to a couple of 100 degrees Fahrenheit, she said. During the real mission, she added, the shield will need to withstand temperatures of about 2,500 degrees Fahrenheit, 1,370 degrees Celsius. At Congdon's invitation, Curtis Wilkerson, an engineer for the probe who also works at UAPL, gently touched the back of the shield, the side not being blowtorched. "What does it feel like?" Congdon said. "Pretty cool," Wilkerson reported. "Nice and cool," he says, "which is just how we like it, keeping the spacecraft cool," Congdon said as the video concluded. In the statement released with the video, NASA officials added that, despite traveling through the coronal zone, which can reach temperatures of several million degrees, whether Fahrenheit or Celsius, Parker will not melt. Why? The answer lies in the difference between heat and temperature. Temperature measures how fast particles move, according to NASA, whereas heat measures how much energy those particles transfer. Since space is mostly empty, there are very few particles that can transfer energy to the spacecraft, NASA officials said in the statement. One of Parker's main science goals is to help scientists better understand the extreme temperature differences between the Sun's corona, the star's outer atmosphere, and the much lower temperatures deeper inside the Sun. While the core is a blistering 27 million degrees Fahrenheit, 15 million degrees Celsius, temperatures in the photosphere are only 10,000 degrees F, 5,500 degrees C. Then temperatures climb again in the corona to several million degrees, F and C. The temperature profile is puzzling because it's unclear why the outer atmosphere and core are so much hotter than the photosphere. With more knowledge about how the Sun's energy gets transferred, scientists hope to make better predictions about solar activity. Solar activity affects how much radiation the Sun transfers through the solar system, and radiation can affect human health in space as well as satellite electronics.